Well, that closely ties into what I do now, which is the fact that it is so plastic beyond development. And that's one of the things that it's not just a visual system thing. It is it is actually much of our brain is still plastic. After I know it sounds, I think that the textbook way of teaching neuroscience and even psychology kind of sensory system stuff has been that, okay, there's this key critical period during which we have to have absolutely normal functioning and exposure so that the brain can develop properly. And that is still true, but it doesn't mean that all is lost if something goes wrong. There is room for reorganization. Even if nothing goes wrong, there is still room for reorganization well into adulthood. And that's one of the things, I think that's one of the things that has really emerged in the past, 10 years or so, and it has received quite a bit of attention. And for that reason, the curious part of it then becomes, okay, we know it's plastic, but what is the best way to elicit reorganization? And that sort of ties into sort of what my lab does quite a bit. We use perceptual learning, visual training as one way to tweak the efficiency of the visual system. I think that's it's a bit of a selfish answer because this ties into what I do. Illusions is a cool thing too, because the illusions is a cool thing because, at least for the illusions that we know what happened in, certainly the understanding is that, of course, the illusion is a product of our brain making mistakes. And then that ties into a whole different question, because it's a matter of, okay, the brain is receiving sensory data, or, I'm sorry, I'm biased, it's all about sensory data, receiving data, and it's what happens objectively is your neurons are firing. But at some point, you yourself need to make an interpretation of those neurons. And so it's that interface of you having to deal with that firing. You're obviously not sitting there going, oh, I wonder what my motor cortex is saying now, right? But like, you're doing that, right? Your brain is, automatically making these interpretations. And so when interpretations go wrong, we have our illusions, right? And so illusions, at least the old ones now, the most popular one, of course, that I still teach in one of my classes is that stupid dress. And that there was nothing new in the dress, right? Because we knew that in order for us to interpret color or any other visual feature, or whatever, let's just put more simply, in order for us to interpret an image, our brain needs to, of course, make some assumption about the light source. And so why do we have some people seeing white and gold and some people seeing black and blue? Well, it's simply because we're using different assumptions. Our brain is using different assumptions of the source of lighting. So for those problems, that's still a cool thing. There are some people who, discover illusions every so often and have them published and then come up with some good theoretical explanation for hey, what happened here, and I think they are interesting. I like illusions in general as a loose category because there's so much we can learn when the brain does make mistakes. That's one of the longer term goals that we do have in the lab. So one of the more specific things that we're working on right now is using perceptual training to alter eye balance, put a little bit loosely. Just imagine that while the two eyes can be just perfectly normally functioning and receiving data, by the time my left eye data, my right eye data reach the back of the brain, my primary visual cortex at the back of the brain can treat the left eye data and right eye data in an unbalanced way. Sort of like, I don't know how to say this a little bit more simply, but it can have a bias. It can be biased towards liking the left eye versus the right eye. And this imbalance occurs in actually 70 to 80% of the population, but it's relatively minor, so it doesn't affect us. But there are certainly populations out there where this imbalance is very extreme because of early developmental deficits, So whether, maybe they had a cataract, or maybe they have whatever injury that ended up having a weak input from one eye when they were growing. And that ends up leading V1 to be biased towards the good eye, and even when they reach adulthood. And so one of the things we're trying to do, firstly in the normal population, but eventually the goal is how can I now take this basic research and translate it to people with these disorders, whether it's due to eye disease or whatever. The end point is still the same. It's an eye balance. Eye imbalance, imbalance in the treatment of the two eyes data by the visual cortex. How can I try to shift this back a little bit in the diseased brain? And so, yeah, definitely, that is, that is the ultimate goal that we would like to do. Of course, science will it takes time, but I think if you keep in mind, is one of these things that I still think about every year when I just have a randomly new idea. I think it's important to think about what is the kind of very, very long-term implication of what you are doing now, and I think that will keep you motivated towards attacking that problem in very many directions. We're not going to write a grant proposal that says, I'm rebalancing, I'm curing all possible eye problems in the world, and that'll happen next year. No, of course not. But yeah, definitely, it's good to have a long-term purpose. Yeah. That's a good question, because I find even my undergraduates don't know what we do on a daily basis. Because when you enter university and you see us in the classroom, and then I realized within my first couple of years on my academic position that you guys think we spend all our time teaching. And then the funniest story is when, like, I remember summer just started, or whatever summer is, like the second term was over. I think they get out here in HKU generally like end of April, and they said, oh my god, what are you gonna do with all of your time now that you don't need to teach? And I said, you do realize that half my job is research. So well, just to give you a brief idea, like on a day-to-day basis, on a typical term. So you can see, like, on my background right now, I'm currently on an academic sabbatical. So this is not a typical semester for me, but on a typical semester when I'm not on sabbatical, I spend 2 days a week usually teaching, and maybe 3 days a week max, teaching and prepping for the teaching. And then I spend, it's very hard to find this time, but there's one day usually I mark off for, like, I call it the selfish research day, where like no meetings are ever booked on that day. And I sit down and I'm writing, or like, I'm one of these weird people who I still really like to touch my own data, even though I have a lab full of, graduate students now who analyze data. But I really like to keep a set of data for myself to run, because that's what got me really interested in neuroscience to begin with, right? Being able to interact with the data myself. So I mark off one day just for that. And then I have one day where I basically give to my research graduate students and my undergraduate project students. And so I call that the meeting day. And usually it's a very bad day. It's a bad day. I'm not sure for who, but for them or for me, but it is. But like, I have a bunch of 30-minute meetings lined up the entire day, and we're doing like progress updates. We're doing problem solving. So it's a once a week sort of, like, they come to me with what has happened in the past week, what problems they have, and obviously it's very important that we catch these problems early, or I know about it early, because then we can solve them. It's important for me to meet with my group frequently to catch these things and to solve their issues. What I will disclaimer though is that my typical week is probably not a typical week for everyone, all different professors out there. That's just how I run it. But like, by and large though, the kind of like, part-time teaching, part-time research is sort of how we function in general with our time. Obviously, I wouldn't be in my job if I didn't like research, but I do find surprisingly teaching to be kind of rewarding. and I don't know if I can help you digest this, but I think you guys, what you need to accept is that professors by training are not teachers. And I think that takes some time to digest, because you just think, oh my God, they're a professor. Why aren't they teachers? Because if you think about how the sort of academic path of a researcher, we do research. We don't train in teaching. And so you'll find that you'll have different types of profs out there. Those who absolutely have the clearest disdain for teaching, and those who really quite like interacting with, you know, their junior counterparts. And I kind of fall in the second category. It like I did when I started the job kind of fear that I might get to hate it, because it's not something by training that we learn, and it's not something that, you know, you automatically think you might be good at. But I think there's a level of reward there when you're teaching. So for me, I teach a lot of neuroscience now, and a little bit of still some psychology, like perception stuff. But when I do go through a very, very difficult concept with these undergrads, and you kind of see on their faces from the moment of, like, you know, you guys have it on your faces, right? When you're very, very confused, there are these like question marks, and then the aha, you know, this is kind of cool, I understand now moment. And seeing you transition between those two phases is actually quite rewarding. And so that, you know, and it's encouraging, because that tells me that, oh, you get it, and you understand now why this, not so much this concept, but why neuroscience as a field is so exciting, because there's so many cool things about it. And so, yeah, so for me, that's one of the surprisingly enjoyable parts of my job. And that's why I think I told you before why I found online teaching to be so difficult in the past year or so, because so in my virtual classroom, I don't require cameras to be turned on, and I'm not sure if that was a good idea or a bad idea. So I made that policy because I know a lot of students are uncomfortable being on camera, and I wanted them to just listen. But the downshot of that is that I can't read their question marks on their faces. And so it becomes much more difficult to understand where the students are. And so, you know, as a teacher, I encourage you guys to be vocal. And that's a difficult thing sometimes in our culture here.